Welcome to video 1. In this video, we will learn the need of SDET, Introduction to Java, writing simple program using Java.
When I say SDET, who's not only the software engineer for testing, including development. I would say software developer, engineer, and tester. So this meaning probably we are like half blended. Now, by the end of the course, you still have the opportunity to be yourself as developer and as well as tester. To be a little more precise, this will be more on the automation. If you have some hands-on or understanding of manual testing, it will be really, really great. But of course, that's not a prerequisite for this course. This course completely targets for somebody to write the test cases programmatically. Manual, we try doing it, but maybe like I maybe uh, quickly rushing for like 10-15 minutes just to give heads up of what is manual. But the whole idea of having the course itself is automation. We'll also try understanding now what tools we'll be using, how we will fit into each of the technology. Now, one is a programming language which we're gonna use it. SDET itself is a very vague word, and one of the programming language which we're gonna use it here is called as Java. So Java, you can write it in .NET, you can write it in Python, you can do it in PHP. There are a lot of languages in the world where you can do testing. In our case, we have choose to have Java. There are some strong reasons why Java is used. Even today, you have like a good market for my Python. Now the question is, hey, Naveen, why not we are doing in Python? Why the market is still open for Java? Why not we do it in .NET? Why not we do it in PHP kind of thing? When it comes to enterprises, Java still takes the lead. For the simple reason, Java, whenever we try talking the number of records, we don't talk in like few thousands. We generally run in like millions of records. There are some good web servers available in the world. Somebody like Tomcat, somebody like WebLogic, WebSphere, etc. So Glassfish, JBoss, and all these people, they are like pretty nice people. They help us to serve the client request for millions of people parallelly. That's something which is pretty important. So whenever you have enterprise uh, requirement, preferably we'll go with Java. And Java itself is so beautifully written. They are more of a platform independent. So what is this platform independent? We're gonna get through this quickly in some time. But I want to write a simple diagram which will make us understand where we are heading for the entire maybe like next 20 sessions. Right. So I have somebody here who's called as Java, which is the programming language. So we're gonna get started with most of our discussions with the Java. If you look at the outline, we will spend like close to about 8 to 9 sessions using Java up to JDBC. It's all about Java. Now Java, on top of this, we have a wrapper, and this wrapper name, who's helping us to do a testing, is called as JUnit. So this guy is called as JUnit. Now, what does JUnit do? JUnit is basically one of the testing framework which will help us to test. It's not only JUnit who has dominated the market. There's another competitor for JUnit, and this guy is called as TestNG. I restrict my training to JUnit because I see that 85% of the applications in the world are deployed in JUnit, and also they have some beautiful reporting, which we're gonna see it in later point of time. Java is something which we are doing it, and we want to use somebody called JUnit. On the other side, what happens? We have a set of web applications written. Now, these web applications which are written in the world, web applications or websites. So we're going to make a difference between what is web application and websites in some time. So these web applications are basically written with the help of HTML and somebody called as JavaScript. They may be having some coloring with something called as CSS. There are a lot of technologies which people write it. Now, again, understanding this website, we're going to do it. Of course, this course does not address us to write any kind of web application, but still I want to run through some basic understanding of how web application is made and how the servers are maintained. Now, what happens when there is somebody as an end user who's going to come, like me and you, are users who load this website, uh, they will probably hit to some kind of web servers which will send and get the HTTP request. I want this JUnit who should help me to understand what is called as website, which is practically very, very, very difficult. Imagine yourself, tomorrow you are asked to write a program using Java or any language. So when I say Java here for like next half an hour, it could be any language. Java, we said that, okay, I have to write a program which will load the browser. It's like, oh, today I have to write a program which will load the browser. Now, writing this needs a lot of work. So it takes some protocols to be understood in Java itself. There are few system services which we have to load it, which will open the browser. Again, I have to tell which kind of browser it is. Either it is a Chrome browser, Firefox browser, or Safari, or IE, or anybody for that matter. They're like browser which should help me to load it. Plus, what happens every time when I have a web application loading it, they're all written using HTML. Just to give a little heads up, what we do is quickly we'll go to one of the website, let's say yahoo.com. So if this is my page, I want to have a look at the page source. If I just right click and click on page source, here I have the source code of this page and how it is developed, what tags they have used, and all these things. This guy will have all the data written in this fashion, which is combination of HTML, JavaScript, CSS. Now, if you just have a look at this, there's a meta character. Let me little zoom it. So that sounds that should be good. So if I just little scroll down, there is a CSS out there. So if I still more do that, it's a pretty huge page. It's a pretty big page. It may take a little time, but anyways, we want to understand this quickly. So what I do is, if you look at this, there's something called as meta. So there are some title characters. There are from href. So there are few links which people have used it. There are few analytics which people have done it, and so on. So now what happens? Eventually, if I want to locate for that element something called as meta, if I want to refer to a meta, or if I want to refer to the body, if I want to refer to the paragraph and all those things, I should have some mechanism where I can write it using Java to locate this element. Because when you're trying to do some testing in the world, for example, somebody like yahoo.com, the idea here is to click something like this. So I have a news out there, I will just have to click on this. Or I have something like a weather, I will have to click on this, or I have a search bar, I will have to search on this. Now, this is something which we want to do it at the end of the day. In order to do this, the whole idea here is to identify somebody called as a tag. So how do I identify it? I have to again write a program. So probably I may have to put it in a box saying that I'll be writing tomorrow, get up, no, tomorrow we get up and try writing a big application which will make all this understand, like tags, IDs, uh, anchor, etc. So there are like a lot of tags which is possible, or meta tags, some CSS, and all these things. Either we can do it, or we have to take the help of somebody in the market. The one person who help us to do all this thing is called Selenium. Luckily, coincidentally, Selenium core itself is written using a programming language called Java. So the compatibility with the programming language Java and the Selenium is very high. So it does not mean that Selenium as a tool does not stop only with Java. They also have expansion today with Python. They also do it with JavaScript. They also do it with the .NET and so on. There are a lot of people whom Selenium supports it. This will be little later discussed, but I'm sure that we are in position to understand when we want to load some kind of web application today from Java. It's something like me and you stand here. When I want to load it, what I do is I take the help of Selenium. What by Selenium, as of now, just try knowing it. Selenium is basically called as an API. API is a set of softwares which somebody has written for us. Just for an example, imagine if you are part of some tax calculation. Now you can do the tax calculation every time, or what you can do is you can outsource it to me. I will do everything and I give you a ready-made package. This package will help you to have that algorithm or the formula. This is something which is called as API. Whenever we try having a discussion here of what is called as API, it's a set of applications or set of program which is written by third-party vendor. We are using it, and with the help of Selenium here, we try invoking the web application or website, and we have a whole lot of job to be done. There's a whole lot of job which you're gonna do it, and the web application will give an acknowledgement and we can put it. Now, on the verge of it, when you want to send the data, you can send the data in one of the two fashions. Either you can use somebody called as CSV files or your Microsoft Excel. That's where most of the time we try doing a data or a database. In my case, I'll be using a database, somebody like MySQL. Again, we are free to choose any database for that matter because we want to test some application like 1,000 times, 2,000 times, a million times. I just want to do some stress testing and kind of thing. I can always do it. So I can pull the data with the database and do the operation using uh, Selenium. When the acknowledgement comes back, I can even keep it the same in the database or in the CSV file. That's where the whole idea of having an application. On the verge of it, we want to go with something called as BDD. For this, we have a specialized guy who is called as Cucumber. Cucumber. And integrating this, we'll do it with another guy who's called as Jenkins. So, who's a pretty well-known guy in the industry who will help us to do automation. We probably call it like CI/CD tool. CI/CD. Anyways, we're gonna talk about that a little later. So we'll have a programming language called Java. We'll use JUnit or TestNG. We use some tools which is already written by Selenium. Selenium will help us to load the browser and identify the tags, IDs, anchors, etc. All these people. Then I can have a web application. Now, Kemi, what happens when I say something called as JUnit? Let me just give you a little heads up of JUnit. If I try writing a Java program, my Java program can only help you to execute it, but I want to calculate amount of time which is required. We can still do it with core Java, but the good idea is to have JUnit. JUnit will also help us to have the reporting. So I can have a nice report given for the developer or the team saying that what is happening in the system. For that reason, we're going to use JUnit. And JUnit by itself is a framework which will help us to run the test case in asynchronous mode. So once we understand what is called as threads, then I can give a nice heads up of what is called as asynchronous. So we tried following something called as waterfall model. Then we had a prototype model. Then we have the AIX model and so on. These days, most people in corporate try following something called as agile. Agile has become a de facto model. Now, there is somebody who is a parent of Agile who is called as V model. V model. Now, V model became like pretty interesting in last decade. If you see last 1 decade, we have V model. If I say Agile, Agile is just a child of V model. The whole idea of having V model is capturing the requirement. So when somebody captures the requirement, the same person or with the same caliber person should do a testing. But our perception of having testing is something here. A developer has to do a testing, the team leader has to do a testing, or a project manager has to do a testing. But we did not involve somebody as a stakeholder to do the testing. Now, in order to achieve this, fortunately or unfortunately, this person who takes the requirement, he is not a technical guy. He is somebody who understands plain English kind of language. I should have a framework which is built or which can help me to test even with the plain language. This is achieved by somebody called as Cucumber. So Cucumber will act as a wrapper for us here on top of the Selenium for executing test case, where all our test case are written with the help of plain English like language. Just below this, guys, there'll be somebody like project manager. So the project managers will have something like component testing. So then we have team leader. So this team leaders will have integration testing. Then we have actual testers. So maybe with people very less experience, like 1 year, even freshers for that matter. They are somebody who does most times unit tests. And finally, we have development. Now, if I want to classify the entire diagram into two segments, I would probably mask this as one big unit because I see that there is no technicality involved for this guy who captures the requirement. If I see project manager, he is partially technical, so we can mark it something like this. And team leader is more technical. I can have the next guy who is a tester. He's little more technical because as you look at the steeper way of the application, people who stand in the development, these people know hardcore technology. They are little less, and team leaders are little less because they get involved in domain and all. But if you look at the outermost sector of people who are capturing requirement and testing, who do the testing here, they are like least bothered of technology. Somebody like I would just say that gray hair or no hair people in the tech, in our corporate field. So they are somebody who does this. For to help these people to understand the application, we use Cucumber. Selenium by itself can be used for web application, even for mobile. There's a pretty well-known guy who does a mobile testing. So if I have a mobile to be tested, I can do it with Ranorex. In fact, Ranorex or Appium or SauceLab, all these people are the wrappers written on top of Selenium. Now the question is, why Java? So why not somebody else in the market? There are like thousands of programming languages which have been using it. So if I just go back, hey Naveen, we were all good. If I just go back to 1970s, we were good with C programming language. So if I come to 1980s, early 1980s, we had a C++. So even before that 1960s, we were really good with somebody called as a COBOL. Or I can go back with the 1950s time or the late 1950s with somebody called as Smalltalk. We had such a beautiful languages, but again, why Java? Somebody who got inception in the year 1990s, and I could say maybe like if you just calculate this, 92 was officially like Java was there in the market. People started using it. JDK 1.1 was there in the market. So today we are in 2018. Well, like it's a long time. I just want to do that. 2018 minus 1992. So that's like 26 solid years. 26 solid years. And trust me, there is no competition for Java when it comes to race. Java has grown to such a level that people who came into uh, manufacturing the programming language, they were almost killed at the inception time. Trust me, after 1992, if you just see the history, it's pretty fun to understand. 1970 C was there, 1980 C++ was there. People forget what is called a C. So a lot of things happened in C++. Now, 1990s, Java came. It's like 1990s, Java came. I just want to keep it here. 1990s, Java came, and we are in 2018. Still, Java is being used. Why people have not changed from Java to something else? Now, the whole idea here is the way how Java is built. So, first and foremost, all the languages apart from Java, all these languages which are highlighted, they are called as native languages. Now, the moment I say something called as native languages, let's understand. I have a program written using a C programming language. Let's consider this is a C program. I call this as a hello.c. So maybe it's a simple program. We're not going to do anything. I just put some dot. Now, what happens when I have this code which is written using hello, which is with C programming language? For this, I need somebody who can help me to compile it. Now, who will help me to compile it? We always know this. There's somebody who is called as a compiler. Now, what my compiler does is the compiler job is to check syntactically and semantically and give you something. So, what we call this as an object code. Now, when I say object code here in our C programming language, if you have your program name as hello.c, you'll get an object code as .obj, which is called as intermediate code, or we call it a deployable code. If you were in an operating system, something like Windows, then you will get something like .exe, since an operating system like Windows will understand exe files. But if I'm working with the operating system like Unix based, we generally get a.out files, which is very similar to the exe file. That's a whole idea of it. The exe file or the out file which is generated is specific to the operating system which you're working on. Today, imagine I'm using an operating system called as Windows. So now when I try using Windows, I will not find anything called as a.out. There will not be anything called as a.out. I'll have hello.exe. For the simple example, it's a Windows-based operating system. Now, since it is Windows-based operating system, I can use this exe to execute. So I can use this exe for execution. So when I try using it for execution, it works locally for Windows itself. Tomorrow, you ask me, hey, look at this, Naveen, this is perfectly fine. We did some good program using Windows operating system. Imagine I have a requirement where I want to run this on a Linux-based server, Linux-based server. So I have Linux here. Unfortunately for us, we will not be able to have the main program language which we have written in Windows and Linux are same. They're not like pretty same. We have to make a tweak because the compiler which you are trying to have it, the compiler itself is written using native programming language. For example, I don't know, just a quick heads up. We'll just go back to our college days where we had this statement called as stdio.h, stdio.h. I don't know how many of you remember. If you don't remember, stdio.h is a header file which will have standard input output operation. But when if you have written the same program using Linux, we would write hash include stdio, right? And probably people from Windows, we had include conio.h, conio.h. But unfortunately, we don't have anything called as conio.h in Linux because conio.h, if I'm not wrong, we tried using conio.h for clearing the screen. So I'm just trying to connect this few dots from your college days where we want to use clear screen, something like get ch and all. But unfortunately, you don't have it. Now, what do you have it in Linux? We still have the support, but these are all written in hash include std lib.h stdlib. So now what happens? The files got changed, the implementations are changed, and the way how it is treated is changed. If I try compiling this guy out there who is may not uh, C in Linux with the help of compiler, and what I get the output as something like a.out, so which is basically like this. Now, what happened to exe? I will not be able to take a.exe, a.out, put it here. I cannot put hello.exe here. These two are something which is really not possible. Now, this compatibility is always there. Tomorrow, imagine I'm working with Macintosh or I'm working with Sun Solaris. I'm working with Google Chrome as an operating system. There are like hundreds of operating systems the company want to invest their money on, but we don't want to have uh, uh, developers sitting on each of the operating system. Rather, we want to write the code in one operating system, and pretty much it should be working in all operating system. That is what the world did not see before 1990s. That's where this person by name James Gosling, who's the guy who came out with the programming language called as Java, did this work. so that you can write the program in one operating system and pretty much put it in all operating system. And he called this as warm. Write once, read many. So that's what the meaning of warm is. So you can write it pretty much in one operating system and try having this deployed in any operating system. Now, the first click of Java happened in 1990s, early 1990s, with the help of Warm. He tried proving few concepts. One is platform independence, architectural neutral, right, and the compatibility. And he also introduced something called as threads. We're gonna do that in little while, all right? Now, how does this platform independence work in Java? Let's have a look at this. If you have a look at this JDK, which is when you click on download, you see also operating systems which has come out, but this has a little story. Let us understand this by diagram. Now, what happened? The problem what the earlier programming languages had is like when you have a compiler in Windows, you have to have the executable code only on Windows. If you have in Linux, only in Linux. If you have it in Mac, it's only on Mac. If you have it in Sun Solaris, it's only on Sun Solaris. Now, this was something which was tightly coupled with all the programming languages. Rather, what this guy did, Mr. James Gosling, he says that, okay, now you're working with an operating system called as Windows. Perfectly fine. So tomorrow you may switch back to another operating system, which is somebody like Macintosh. So let me keep a Macintosh here. Macintosh. Okay. So day after, I may be working with another operating system which is called as Linux for whatever reason. So there are like so many operating systems which you're working. So what this guy does is he says, look at this. This time, when you try writing an application, which is like hello, we call this as Java. When I have a program written using Java, which is basically a complete object-oriented language. We're going to talk about that a little later, but I just keep it a little short, which will have a class which is called as hello, and I'll have some blah blah blah. So that's some story which we're going to write it over a course of time. So this is where the class will come into picture. When I have this Java code written, this time when you compile it, I gotta generate something which is called as a object code, which is also called as an intermediate code. Now, what code is that? This code is called as bytecode. Wow, that's something pretty interesting. When you say something called as bytecode, do understand the byte itself is a concept where every operating system is derived from. That byte here in Windows is same as Mac, is same as Linux. Now, when I say byte, there are few standards which everybody in the world have to undergo. You just cannot say tomorrow you come out with an operating system. We cannot bypass. We have to follow it. There are few people in the world. One is called as ASCII. There's somebody who is ASCII is American Standard Code for Information Interchange, something like this. We had ANSI. Now, from 1990s onwards, people started discussing that ASCII and ANSI are pretty fine. We're not denying it, but they help only English language. But if I want to have localization and globalization, where I want to have my own language to be printed or to be used in programming language, that was not possible. They came out with something called as Unicode language. Now, don't remember very, very, very cautiously, Unicode, one character is 2 bytes. One char is 2 bytes. Do remember. So if I go back to your C or C++ programming language, where we had a char, the char was always 1 byte. We used to say 2 raised to 8. So here, any minimum to minimum character is about 2 raised to 16, which is about 2 bytes. So what this guy did is he created something called as byte language. Now somebody has to understand this byte language, right? Now to make somebody to understand byte language, what these people did, they created their own software. They created their own software and they started calling this as um, JVM. Here, when I try having in the previous diagram, when I try having hello.c, when the compiler does, somebody has to create obj file. This obj file in the world was created by somebody called as operating system. The operating system came and helped to create hello.obj. But this time, the story gets changed. The story gets changed. If you want to compile and get the data done, this compiling is done by somebody called as JVM. Now, what is JVM? JVM is only guy who's like what is just a mission. So if you understand this, is a virtual mission, but it is Java's virtual mission. So now it says, okay, now I have a program which is called as hello.java. The life cycle of hello.java is completely spent inside the JVM. The life cycle of the program is kept in JVM. What is your Windows doing it? Now you can ask me, hey Naveen, why do I need something called as Windows when JVM can do everything? Very cautiously understand there is something called as processor in our world. So we have processor. Processor is something like a physical storage. When I go and buy the computer, the processor is kept. Now, who is the owner of the processor? The owner of processor is always the operating system which you have installed. Where JVM is a piece of code which acts like a virtual machine, which will take the time from the Windows and says that, hey, look at this, Mr. Windows. You don't have to understand what I'm doing it here. I have the same credentials as what you're doing, except for I cannot talk to processor directly. The only thing what I'm expecting you is you give me the time of a processor for some time. Now, as a good operating system, the operating system will always give some time for execution for each of the processors. One of the process happened to be called as JVM. So a lot of people call it JVM or people call it Java. Both refer to the same. But when people call it JDK, that refers to something else. So just a quick differentiation, you can call this as JVM or people can call this as JDK. JDK, I'm sorry, this is Java. I'm sorry about it. You can call it JVM or Java. Both refer to the same who helped me to compile. So imagine yourself, once I have a bytecode, somebody has to understand. Who will understand this? JVM understand. What is this bytecode? Obviously, this has a file extension. So here in our previous diagram, we had obj code. We call this as object code. Probably in your college days, you called C as an intermediate code is called as object code. Coincidentally, this guy by name Dennis Ritchie, he created the extension as .obj. It was pretty easier for us to understand. Here, the things get little different. That it is not called as object code, rather it is called as a class file. It is called as a class file. So the class file is a object code which is kept in your JVM for execution. Now, who will understand this? JVM is understanding. So imagine yourself, tomorrow, what we do is we will take this code, which is hello, the class called as hello. I put it in Macintosh operating system. I still undergo the same process of having compiling. I'll do the same compiling, assuming that I will also have JVM here or Java. Or I can take hello class, I put it here, even here, the same old story will happen of compiling, and even here I'll have JVM or Java. Tomorrow, you have any operating system, the moment you have the ISO certified as an operating system. So, what JVM will do is they'll back you and say that, okay, boss, we will give you a JVM because I see that you're growing it good in the market. We want to give the JVM. Now, what happened? The code is written in Windows and the person is understood by JVM. The code is written in Macintosh, understood by JVM. Code is written using Linux, understood by JVM. So if you look at this, in all three places, who is common is this guy, who's JVM. Who's the owner of JVM? It's Sun Microsystem. Who's the owner of this JVM? It is Sun Microsystem. Who's the owner of this JVM? It is all Sun Microsystem who has done the job. So it is Sun Microsystem those days. Today it is acquired by Oracle Corporation. So what happens? You can pretty much write the code in one place. They can be accessed in any operating system. This was one of the first trap or first way how James Gosling captured the entire market in the world. So now this was one of the trap, but people were not really satisfied with this. We want little more. Let me tell you one more story. One more story here. If you see this history actually really hard in our programming as well, because earlier to C there were good programming languages which is called as Smalltalk, and COBOL is a child of IBM. IBM almost took over the world. So I would still say IBM was the only company those days who had programming language, the desktop or the monitor, printer, plotter, keyboard, you name it, IBM manufactured it, right from the software to hardware. So the full stack was only IBM. They pretty much ruled the world for long time, not even allowing other competitors to come. That was broken by a guy who was working with Bell Labs, name called as Dennis Ritchie. This guy almost break the rule of IBM. Now, what he did is, first and foremost, if you want to run COBOL, you have to run with COBOL system itself. You cannot run with something like Intel or AMD kind of systems. So even if Intel was there as a manufacturer, they were adhered to the rules of COBOL. Now, C programming language came. C was the first programming language where you can directly talk to hardware, or you have a direct connectivity with logical devices, or you can control the hardware or kind of thing. People are like gone crazy those days. 1970s people like to see so much that every corner people came out and started having they started reaping the benefit of C. And moreover, C is an openware language, open source language. A lot of universities came into the world to support it. There are some good universities even today. The entire source code of C programming language is with this guy's MIT. Oxford was there who helped, Harvard, and every country, most universities, top-notch universities came and took the power of C. They started using it. So if you see the penetration of C language, it went really high. So as a language which is called as C, which penetrated so much in the market that it was very difficult as a competitor to come. And they were like pretty cool features. They had something like looping, loops, conditions, um, compiling mechanisms, compilation mechanisms, and all these things. So this was cleanly understood by another guy, but unfortunately, C did not do one thing. They did not give the touch of object-oriented programming. So this was cleanly overtook by another guy who was called Strauss-Trap. He introduced another language which is called as C++. Strauss-Trap, what this guy did, he cleanly copied C compiler because C is an open source language. He cleanly copied C, and what he did, he added oops. Now, what is your oops? He tried introducing everything what is there, plus he had oops. So what is there in the oops? You have inheritance, polymorphism, encapsulation, abstraction, plus some error handling. So he understood that, okay, whatever I did not had it in C, this guy did it. So C++ became too much popular. Even today, if you are writing some program on semiconductor devices like remote controls, micro ovens, or maybe like Bluetooth programming or aircraft, all this thing still happen with C++ because these languages talk to memory directly. And this was almost the end of the road for any developer who could come, or anybody who has a researchers who could come in the world to invent a language, right? C++ still they have a beauty of it. This was again captured by another guy who is called as James Gosling. What James Gosling pretty much did is he copied what he wanted from C and C++. From C and C++, what he did, he just went on to copy. He just went on to copy something like this. Okay, so let's put it. So he went on to copy this part from C. From C++, he took all this. He also left a lot of things which wasn't required. Probably in C and C++, we would have come across with something called as pointers, where you want to directly talk to memory. There was something called as struct. There were way how you have to manage the file. There was something called as union and all these things. He just took it out. He told, okay, that is not something which I want to have it. Rather, I want to introduce a language now which copies a lot of things from C and C++ and introduce Java. And you have to understand very cautiously, even today, why Java is still there in the market is not because of Java. I'll not go with that because Java just uses the syntax of C and C++. If you're good at syntactically vaguely remember what you have done in college days with the C and C++, you're pretty much good here for syntactically. So he took all this looping conditions, compilation, he took it out. He did not want it what is called as pointers and all those things. He took all the OOPS languages. The error handling is something which he did not like from C++. He just took that out. Compilation he did not like. He took that out. Plus, what James Gosling did is he introduced his own features, what is required for Java. So what he did, he introduced threads, collections. He got applets. So applets is something which is outdated today. But if you have a look at the early 90s, applets was like booming. Wow, people were really fascinated where you can have a graphical user interface kind of thing. And you have something called as, of course, Oops was there. Oops was there, which was very cleanly used. Then you had a direct connection with the JDBC, RMI is there. There are a whole lot of new things what Java had it. Plus, we had something called as platform independent, what we had just discussed it. Now that's something which made Java to sustain long time. In fact, today Java itself is penetrated so much, even in near future, it cannot go off because there are a lot of languages which has come out of Java. Somebody like Groovy, Scala, Ruby. There's a nice statistical language which is making a lot of sound in the market when it comes to machine learning called as R. They are all built using Java. They're all built using Java. Hope this is good enough for us to understand why Java is required in the market. So this is nothing with the technology. It's something which I have researched it over a course of time, and I wanted to share this. And we have to have a good no, analysis of where we are heading and why it is Java. Why not some other programming language? So let's move out our discussion from our little theory. We spent quite a good time understanding the need or the programming language, where we are heading towards, and kind of thing. To let's be a little more technical now. So I may need Java or JDK 1.8, 1.7, whatever you feel like. That's what we wanted. So what I have done is I have installed a Java on my system. Once after installing, the installation is kept in my drive here. It's a C drive. So I should find somebody called as Java out there. So here I have like two folders. Now, pretty important to understand. If you buy a computer or a laptop from the shop, you will not have JDK, but you will have a JRE. So let's understand JRE comes by default. You don't have to have any additional software to be installed to work with GRE, because most of our applications today are built using Java. Even web applications are built using Java. So JRE is somebody who's called as a runtime executor. So Java runtime executor. I want to show you one more diagram when it comes to JDK and JRE. So first and foremost, let me get into JDK, which is a superset of JRE. Now we always say JRE is one instance of JDK, right? So now, when I get into JDK, when you have installed this, even in any operating system, you will find a directory structure very similar to this, very similar to this. So there are like it depends on the kind of installation which you would have done. If you wanted a source, there's a nice folder here, which is a zip folder, which will uh, have all the source folders. In fact, the Java itself is kept here. Which just out of the interest, you can have a look at this. There are some nice packages which people have written. If you want to know how our lang package does, all these things are kept. So you name the requirement, you have it. So a lot of times I try using a few jargons in the way on the verge of our training, as we can see the source code back. But just to give you a heads up, this is where all the source code of the Java itself is kept. So now, apart from this, there are like a few more folders out there. Now, did you cautiously see that there is something called as JRE? There's something called as JRE. Now, the content of this JRE and the content of this JRE, both are pretty much same. They don't differ. I'll tell you why it is also in some time, right? But just have a heads up as there is a JRE here. Plus, there are some list of libraries. Out of that, there's one library which we always needed, which is called as DT is there, tools is there, there. Okay, so not here. I should find it in bin. So I should find it in bin. There are like some good libraries and some executables which we're gonna use it. Out of that, let me make a list of few people whom we discuss it today. Now, first and foremost, there's somebody called as Jar. So Jar is a guy who will help you to bundle the entire code which you have written for the deployment. So he's called as Jar. We're going to do that. There's somebody called as Java. Java is an interpreter. Java itself, in fact, a lot of times we use Java as a word. Java is called as a Java interpreter. We're going to talk about this. And there's somebody called Java C, Java Doc, probably Java P, and there are a few nice statistical tools which probably needs more time for us to understand, more of a development activity in terms of performance and all. So if you see Java Depths is there, Java Depths is a new feature from JDK 1.8, which will give you the dependency of that class with other classes dependencies. Java Hat, there is JInfo is there. JJS is Java JavaScript. It is also possible from JDK 1.8. You can write JavaScript in Java itself. So this is like whole big elevation in the world when it comes to technology. JJS is very very powerful tool here. There's a nice tool which I like it called as JStat. JStat will give you a statistics of your application. It's something like this. It's something like this. If I just go here to Task Manager, in my Task Manager in Windows, uh, I can see what process I've been using it. So I'm using Google Chrome. I have a Zoom meeting. I have a Paint. I have some service, anti-malware running. I have some task manager running and all those things. So if you want to understand this in Java, then you have a nice tool which is called as JStat. So JStat, this guy is pretty interesting tool. I did some good training there for understanding. So there are a whole lot of tools out there which will help you to uh, identify the needs um, uh, depending on the requirement. But in our case, we'll limit our discussion with what we are concentrating on, only to execute the code. So here, what we do is we will try writing a Java code. So we'll try writing a Java code. So let me call this a little better just to start with hello world hello.java. Now what happens? This code, when I try having, this has to be compiled. So this has to undergo something called as a compilation. So compilation. So this is done by Java C. Now, what is my Java C? Java C is a compiler. Do be very careful to understand when I try saying Java C. This guy will check syntax and semantic. So he will check only syntactical and semantic. So parallelly, let me also write the code. I'm not going to start, let us not start our story with using something like IDE. There's a good IDE out there in the market, somebody called Eclipse, IntelliJ, NetBeans, JDeveloper, and so many people. Out of that, we're going to use Eclipse, which is openware. I'm sure that most of our companies will use Eclipse. That's one reason I've choose to have Eclipse. We will get started to write a Java program on something like Notepad. So Notepad. This has nothing to do with Eclipse, but I just want to show how things work behind the screen. And this will be the first and last program for us using Notepad. Notepad. Now, one important thing you have to understand whenever you try writing Java program, everything has to be wrapped inside class. Firstly, C++ is a OOPS language, absolutely fine. Java claim they are like OOPS, but they are 100% OOPS language. So the moment you say something called as OOPS language, everything in the world will get wrapped inside the class. If you have tried writing any program using C++, I'm sure that you would have written something called as a class. You did something here. Maybe you did declare some variable called as x and blah blah blah. All those things. You had this main. I don't know if you could remember this. If you come from C++ background, right? So that's what you pretty much did in C++. This is fairly good because this is wrapped inside the class, which we can treat this as object. But the int main is not wrapped inside the main, isn't it? So I would still consider C++ is a OOPS language, but it is not 100% OOPS language. Whereas in Java, you cannot write any statement or any executable statement outside the class. It is very clear that any business logic you want to write it, you have to put it inside the class. Hope this makes sense. That's why we say Java is 100% OOPS language. There are few good blogs in the world which will tell Java is not 100% OOPS. They are 99.9% OOPS. I still go with 100% OOPS, and I'll also tell you why people say 99.9% oops, it's not 100%. We're gonna talk about this. The whole exercise, if you're gonna do it for like this week, you'll understand why it is called 99.9% oops, why not 100% oops. But as of now, let us understand it is 100% oops language. Now, I'm gonna have a logical name for the class, which is called as hello world, and a skeleton structure. Very importantly, if you have a class and if you have a curly braces, now this class is ready for compilation. So be very clear. You don't have to have any executable. Even without any executable, this is good for compilation. Just to prove this point, what I do is let me go back, save this. I'll click on save as. I have created a nice folder here in our C drive, online training. So I have SDET May 2018. So here I create a folder which is called as Java programs, right? So Java programs. I want to save this with .java as an extension. I call this as hello world dot java. So the file name is called .java. So I'll save it. So let me go back here in my C drive. In my C drive, online training, May in Java programs. This is where we are. So at the same time, at this place, I'm gonna open the command prompt. So when I say dir, it gives you a file which is called as hello world.java. In order to compile this, I invoke a tool which is called as javac. Look at this. The moment I put javac and say hello world, hello world Java, what this guy does is he will check syntactically and semantically if my program has error. If it has error, it shows it. If not, it creates a file which is called as class file with the same name, hello world.java. And one important thing to be understood, when I tried saying Java C, it worked for me, but for you, it may not work. If you still want to take initiative and try writing a program on Notepad, and this we have to do it by setting the class path on our directory. Very importantly, the steps you may have to, everybody, all of us have to do this exercise after installation of Java. So I'm sure that people coming from Macintosh, what you can do is you can do something called as which Java C, which Java C. So when I do this which Java C, it will give you similar to this. This will be the only step which might be differing. But anyways, people coming from Windows and even from Mac, you may just have to copy this. Okay. So now since I'm in Windows, I just want to show that run. You'll be going to program files or the place where your Java is installed, JDK. You have to find a folder which is called as bin. You have to come inside. So you have to come inside. You got to copy this address bar. You may have to copy this address bar. Right click, copy. Copy. Okay. Now, on your computer, on your computer, right click, you have something called as properties. In properties, you have advanced system setting. Here you have environment variable. Here, you may have to check if you have something called as path. You have something called as path. In my case, I already have path. If you have it, you will select this and edit. If you don't have it, you may have to create one. Again, you have two blocks here. One is user block, one is called as system block. You can choose to have any one of them. The only difference between these two blocks is the user variables are limited to the user to which you have logged in. The system, once you set it, if you are trying something in your system, in your home PC, you can try access because it's your own computer. So here, if I put it under the path, this will be set for entire system. So I can go back, select it, edit. I've already put, but just to give you heads up, you can put this here, up to bin in the path, very cleanly. Is that good? So I'll also show this, how things can work. Maybe a nice documentation here. I'll just put this here. So once after installing, set the path, set the path in your OS to access command line. So let's put the steps. So first is go to installation directory up to bin. So in my case, it will be this directory. So because I've installed the program files, Java, JDK 1.8 or whatever. So people from Unix or Linux or Mac, Linux or Mac people, you may have to do which Java C. So this will give you the same thing. So instead of navigating there, you may have to do the same thing. So, anyways, so once after this, on your my computer icon, right click. Once you right click, properties. Once you do properties, you may have to click on advanced settings. So that's what we did it. I hope you remember that. So here on your computer, properties, advanced system setting, this will give you a pop-up. Click on environment variable. Click on environment variable. Environ variable. Then, then you may have to take all right, yeah, environment variable. In one of the two places, either in the user section or in the system section, you may have to uh, create a variable, yeah, here under user section or system section, uh, check if you have path, if not created, if already there, then edit. So once after you edit, you have to you may have to do something like this. Anyways, I'm gonna show that now. So on your path edit, you have a lot of variables. You may have to add a new variable, and paste it. So you may have to add a variable and paste it, right? So here, add a variable and paste copied text. You may have to copy it here. You may have to copy it here. Hope this is good. So people coming from Mac, for Mac people, for Mac guys, so the step two will be a little differing for you. So you may have to just write, go to terminal. Under terminal, what you're going to do is export, export, export path. Make sure it is in uppercase. The case should be exactly same. Path equals dollar path colon the output of the which. So when you say which Java C, it will show you something, right? You may have to copy and paste it here and hit enter, right? So in my case, in your case, it will look something like slash usr slash bin slash java C. Yeah, so something like this. It'll look something like this. I'm not pretty sure. No, I may just have to do which on Macintosh. So this is one step. You may want to do it in case if you want to execute from the command line. That's the only thing. If not, you don't need it really. What I did, we did something called as Java C. When you say Java C on your terminal, in fact, have a look at this. When I say dir, there is nothing called as Java C application. You don't have Java C. You have only two applications. One is called hello world.class, hello world.java. When you say Java C, the moment you hit enter, what happens? Your operating system will find in the current directory. If it is not there in the current directory, it will go to this place. It will go to this place and scan everything which is there. There, it will find one of the place where Java C is found is here. In my case, I put a variable called as Java home. Java home is everything apart from bin. So it will go to bin, under the bin, under the bin, here, under the bin, program files, Java, JDK, under the bin, here you should find Java C. Here it will find Java C. Then it invokes this program here. It invokes this program here. So let's say Java C. Anyways, keeping it little short. So what happened is in our diagram, when I when I say hello.java, when I compile it, the Java C will only check syntactically and semantically and give you the object code. The object code is a class file. So the object code is a class file, which you can see it here. We had hello.java, which is our source file. This file is called as hello world.class, which is the same name. Now, if I go back to the code, what I have written is only this. But unfortunately, this code is not ready to execute. In order to make this execute, we may have to write some additional data. So if I just go back to our discussion, what we've been doing it, you remember we had always written main. The same story will fall here in Java as well. So the way how it works is this. I'm gonna write the statement and I'll explain it. Public static void main with string args. All right. So this is what we have to write it every time. This will be like very basic for us to understand. Let's get through this quickly. Okay. Here. Yeah, this is more at the architectural level to understand how Java will work with this code. All right. So first and foremost, we have to understand there is somebody who is called as operating system. In my case, the operating system happens to be Windows. So Windows would be my operating system. What happens? Windows is an operating system which has the capability to execute multiple processes. So in my case, if you see, there are a lot of processes. I have open file explorer is there. There is some sticky notes. There is a Chrome. There's a Zoom, Excel. Yeah, there is some nice paint which we have done and all those things. In addition to all those things, I also need Java. So imagine I have MS Paint, I have Excel, and I also need, for some reason, Java or JVM, whatever. So a good operating system is somebody who will not deny the execution of any process which comes on the words. That's what your good operating system will do it. Now, what happens when you have Java? For some reason, Java has encapsulated a program. Now, what is my program? Today, my program name is called as Hello World Java. Now, what happens when I invoke the compiler, in order to invoke this compiler, I call something called as JavaC. When I invoke compiler, what this guy does is it will help me to compile it. It will help me to compile it and create a nice bucket or a nice object in the world, which will be stored in some special place. This place is called as a heap place, which we're gonna talk about this. But as of now, let's know it. There is something which is kept. Likewise, I can have hello world, I can have employee, I can have customer, I can have hundreds of classes which you can probably have it here. They're all created and kept inside this environment. This environment, if I want to execute, it has to be executed with somebody with the help of a processor. But fortunately or unfortunately, who's the owner of processor? The owner of processor is your operating system. Now I have to take this block of code and I have to give it to OS, but I cannot directly communicate. Rather, what I do is I'll have somebody who is intermediate, and this person name is called as Java. So what this guy does is he will take this piece of code and give it to operating system, and the processor will get executed and does the job in my console. It will do a job on console because we are executing everything on the console. That's why. Right. Now, very important. We tried writing something called as public static void main. Let's understand. Imagine yourself in the entire world, the busiest guy is not your MS Paint, not your Excel, not your Java, or whatsoever. The busiest guy is somebody called as operating system. For the simplest understanding, the operating system is somebody like a garment. The operating system by itself does not do anything, but a good operating system will do efficiently when the job is given. So this is like a pretty big code for any operating system guy. Operating system by itself will not do anything. And if you give a job to operating system, a good operating system will do the given job efficiently. That's where the whole idea is. So I have the operating system. So what operating system does, it keeps executing multiple jobs. It keeps executing multiple jobs. On the verge of executing multiple jobs, each job will get shifted, and this is called as context switch. This is called as context switch. Now, what happens? Operating system cannot only execute Java; it has to execute Excel also, MS Paint also. Tomorrow you have one more application, even that has to be executed. You may just have to understand operating system is a very fast guy. He just comes and checks. Oh, boss, are you ready, Mr. Paint? If you're ready, come execute. If you're not ready, I'll move to Excel. It'll ask Excel, hey boss, are you ready? If you're ready, I'll execute. If not, no. The same thing will happen for Java also. Hey boss, Mr. Java, are you ready? If you are ready, I'll execute. But the whole idea is if you have written a code, this code has to be exposed to operating system. In order to make this code exposed to operating system, we will write it as public. Public is one of the access specifiers in the world. So public is one of the access specifiers in the Java, which will help us to make its visibility to whatever extent. If you have public as a visibility, it means it is visible to everybody in the world. So make sure if you are writing a main, then it should be public, right? Now, what happens? Now, what happens? I tried saying this. This has to be stored in some place which is called as heap. Now, heap, when it has to store it at the runtime. But here the whole idea is when operating system comes to talk to Java and says that, hey, Mr. Java, are you available for execution? Then Java has to well create this object, keep it ready to give it to operating system. Your Java cannot tell operating system saying that, oh, Mr. Operating System, wait for like 5 minutes. I'm just loading in the heap where this object is kept. It will take like a couple of seconds. You may have to help. Then operating system says, boss, I cannot do that. I'll move on to next job. Rather, what I do is whenever before the operating system could come, Java should be ready with this object. In order to pre-initiate, we call it as static. I don't know how many times we have used it. A quick understanding of static, quick understanding of static here. Uh, of course, I'm trying to talk something in C and C++. In C, I'm sure that we have written this program, uh, int x, printf, percentage d, x, right? In C, it will be a junk value. Now, when I say junk value, it is just an arbitrary value. We just puts it because x is pointing to some logical address. It just prints it. But now the whole idea is if I want to get something like zero every time, definite value zero, to make sure that it does not, make some nonsense in our program. So what we do is we'll prefix this with static. The moment I prefix this with static, this meaning I have to initiate the value of x before using x. In similar understanding, what we got to do is here we say it as static. This meaning before your operating system could come and access this object, when I say static, it means pre-initialized and kept, right? Then every operating system has to keep a track of what is happening. So if you have a program which is written here, when you say void, I don't want to return it to operating system. I'm just saying that the Java application doesn't have to return it to operating system. Rather, it will be returning it to Java itself. So to make sure the output of this will be captured only by Java and not given to somebody as an operating system, what we do is we'll make this as void. And conventionally, people have tried using what is called as main, and the main remains just again. Yeah. When you say void here, if you just have a look at this diagram, the output of this or the execution of this has to be acknowledged. I don't want this acknowledgement to be given to operating system. This does not happen. I want the acknowledgement to be kept only by Java. That is one of the reason will always say it is void. It is always void. Uh, as an example, if I say maybe like I will just have to show this example. Okay, let's do this here. Yeah, this is one example. We did it. Okay, okay. So here it is. If you just have a look at this diagram here in class hello, when I compile, I don't want to have the compilation and execution acknowledgement to be given to Windows. Rather, the execution acknowledgement is completely kept with Java itself. Just to make sure this, we will make this return type as void. We don't want the program monitoring to happen by the operating system, somebody like Windows or Macintosh. Rather, it should all be monitored through Java itself. For this reason, we make it void. I have a pretty interesting statement here, which is called a string args. This is the trap in Java. This is how most times the platform independence, all this blah 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 things will happen in the world. So to understand this better, imagine yourself with this diagram. With this diagram, uh, I have somebody as the operating system, right? Which is operating system. Here I have an operating system, right? And I have an end user who comes to talk to Java. So today what has happened? Java is one of the applications which is there. Now what happens if I'm an end user who want to talk to a program like Java? In such case, passing the value to the Java is directly not possible. Rather, what your operating system does keeps everything in a place, and this place is called RAM, which is random access memory, or you also call this, many times people call this as primary memory. So whatever you feel like. So this is called as primary memory. You make a request, it comes to primary memory, and from primary memory, the data gets flown to somebody called Java. Java does an acknowledgement and gives it to operating system. The operating system gives it, the operating system gives it to the console, and the output is view. The whole idea here, when you want to talk to Java, that's not possible. That's not possible. Rather, you have your set of values. You have your set of values. All the set of values has to be given to operating system. Now, that is one reason. If you just have a look at this diagram, this diagram gives you a lot of story out there. This diagram will give you a lot of story. Every job in the world is done by processor. Every job in the world is done by processor, and any value which you want to put it in your Java has to happen through some mechanism. So there is one common code which these two people will use, and this is something called as RAM. So what happens? You want to make a request to operating system, you got to give it to the RAM will take it and give it. Now the question is, what value are you passing it here? If I want to pass integer, float, double, or image, or video, audio, photo, or all these things, or a string for that matter, I should have a mechanism where I should be able to pass any kind of value to my Java program. So in order to do this, what these people have done is from Sun Microsystem, they have written something called as a string, which is basically a wrapper class. When I say this as a wrapper class, which is a class on top of a class, right? A class on top of a class, which we will be spending some time understanding what is a wrapper class, how it works, and all those things in some time. So now understand this. I have string. The variable name I'm using is args. Again, you don't have to use anything. You can even use something like test. Perfectly fine. So just by convention, I'm gonna use as args, and it is an array of it. So what I do is, since it's a wrapper class called as string, it is possible for me to send any kind of data. Just to prove that point, here, I can send hi, which is obviously the string. I can send something called as 10. The 10 for us, it is looking like integer, but in reality, this 10 is actually a string which will be parsed inside our application as an integer. I can write something like 23.3, which is a floating point value. Here it is a string 23.3. In reality, we can convert or parse this as uh, something like float or double. In similar fashion, imagine if I go ahead, I taking this image, I'll save this for a minute. Now, if I open this, it looks like image, but in reality, if you ask me, hey Naveen, what this file is all about, then I would say this is a string file. It's just a string file. Just to prove that point, what I do is let me right click. I'll go back, edit this file. Okay, open this with Notepad++. When I open this with Notepad++, you see that it is all combined with characters. There's nothing special about this. There's nothing special about this. So there is a character called as I, D, A, T, X, cap. There is a special character here and all these things. There is a registration symbol. There is a PNG file. There is a sub, all these things. So I would still see this file can be opened with a notepad or a text pad for whatever matter. When I open this with an application, something like MS Paint, it looks in a paint fashion. If I open this with a notepad, it has a text. So now what happens? If you consider this guy, if I consider somebody here, I can even pass a file which is called as img.png, which is a file, which is an image PNG. This can be treated as a string, and I can process this in Java. So pretty much what happens if you have a look at this program, the string can take anything and it can be processed. I can send an image, I can send a photo, or I can send a integer, float, double, anything for that matter. So just to summarize, the public will give an access for operating system to have a look at this program, initiate before the operating system would come. That's what we're going to do it with static. The void will tell I don't want to return any value to operating system. Main, it is just copied from C and C++ or earlier programming language. Any value in the world, if you want to send it, they can be sent as a wrapper class object, as string. This guy can take any value for that matter. So that's one reason they have kept it as a string. They did not keep it like int. If you keep it like int, you can only pass int. If I keep it like a float, you can keep it only float. But when I say string, you can pretty much pass anything in the world. Now, the whole challenge as a developer like me and you is to understand what is there in the string, which we're going to do it in some time. So we'll be passing some images, we'll be passing some float, double, all this thing, right? So if you want to print it, I can take the system control and I say the output of the system by default it is the console, and I want to invoke println. I'll say welcome to Java. All right. So that's where our first program will do it. So let's go back and compile it. So here I'll go back and compile it, which Java C. Yeah, it works well. But if I make any typo, so I missed a semicolon particularly when I say dir, it has a file which is called as class. For some reason, I just want to open. I just want to open this file to show you few quick things. Here you have a file. So what I do is, I'll keep this little away. Here you have a class file. I'll go back and delete it. I'm just deleting the class file. Here I say Java C hello world.java. When I hit enter, it gives you an error, and you see here there is no file getting created. There's no class file getting created because the Java compiler will give you the class file only when your program does not have semantic and syntactical problem. So it says that, okay, there is an error where it is expecting you to put semicolon. Let's go back here and put semicolon and go to file and save this. Once after save, let me just check if I could work here and do a up arrow and execute it. Yeah, it has created a file which is called as a class file. Now this file is for execution. This file is pretty much for execution. So here, very important for today's discussion, have a look at this. What we did, we had a program which is called as hello.java. We compiled it, it created a class file. Once after I create a class file, once after I create a class file, I have to see the execution. I have to see the execution. In order to execute, you will invoke somebody called as Java. Somebody called as Java. Do remember, Java as an application will take an input of a class file. So when you have the class file generated, it is guaranteed that it is passing Java compiler. Since it passed Java compiler, it does not have any problem with syntax and semantic. So I could say this class file is a full-proofed class file which does not have any problem. I can invoke it. In fact, here I have Java interpreted. Now, if you try knowing the difference between the compiler and interpreter, compiler will take the entire code and then compile it. That's what your compiler did till here. Whereas the interpreter does not do it. The Java interpreter will execute line by line. This is one of the reasons we say Java is super fast because it knows that the code is compiled and it is ready for execution, and it just goes ahead and interprets each of the line without validating syntactically and semantically. Keeping this in mind, let's go back and say Java hello world, enter. Hey, it says welcome to Java. That successfully we have executed the first program with our command line.
Thank you for watching. See you in the next video.